Hello everyone, welcome back to the channel. In today's tutorial, I'll show you how to create a Sentinel-2 satellite time-lapse animation in Google Earth Engine covering the period of 2017 to 2026. We will use Sentinel-2 surface reflectance harmonized dataset, apply cloud masking to remove cloudy pixel, generate annual cloud-free median composites, and combine them into a smooth satellite animation like as you can see on my screen now. By the end of this tutorial, you will know how to create both GIF and MP4 animation directly from Google Earth Engine, making them suitable for research, presentation, environmental monitoring, and social media content. So, without further delay, let's get started and explain the code. And before explaining the code, let's discuss how we will do this. So before we start writing the code, let's finish understand the complete workflow shown in this diagram. This workflow summarizes all the steps required to create a Sentinel-2 time-lapse animation in Google Earth Engine. Understanding the workflow first make the code much easier to follow. Okay, so step one is the region of interest. So the first step is defining the region of interest or ROI. The region of interest is the area where we want to create the animation. Instead of processing satellite imagery for the entire world, Google Earth Engine only process images covering our selected study area. And the second step is load the Sentinel-2 imagery. Next, we will load the Sentinel-2 surface reflectance harmonized. The Sentinel-2 is a multispectral satellite developed by the European Space Agency that provide free high-resolution imagery with revisit times of approximately 5 days. We will collect the surface reflectance for this tutorial from 2017 to 2026. Then we have cloud mask. The satellite images often contain cloud that hide the Earth's surface. To solve this problem, we apply cloud masking using the QA60 quality assurance band. This remove cloud and cirrus pixels, leaving only clear observations. And then we have filtered it by date. We have a specific date for that. We are using 2016 to 2026 onward. Then we have annual median composite. After removing cloudy pixels, we generate one representative image for each year. Like instead of selecting single satellite scene, we combine all the cloud free images from that year using the median composite method. The median composite have many benefits like reduces noise, removes remaining cloud contaminations, and create a clear annual image that represent the average land conditions for that year. After that, we have clipped it to our region of interest. Then we have the RGB visualization. Once the annual composites are ready, we visualize them using the natural color combination, like B4, B3, and B2 for the natural colors. Then we have created a annual image collection. Like each annual composite is then stored in a new image collection. This collection contain one image for every year from 2017 to 2026. Arrange chronologically this sequence of the year images from the basis of our time-lapse animation. Then finally we have generated a GIF, a video, or MP4. So after creating the annual composition collection, Google Earth Engine convert the sequence into an animated video. So the MP4 format provide better visualization in a better resolution and smoother playback, making it ideal for presentation, conferences, or YouTube videos or anything. Now let's discuss the code line by line. Okay, so these are the comments lines. They don't affect the execution of the code, but describe the purpose of the script. So in this tutorial, we are creating a Sentinel-2 time-lapse animation from 2017 to 2026. Okay, so first we center the Google Earth Engine map on our region of interest or ROI, and the number 9 represent the zoom level, making it easier to visualize the study area. And then we have map.add layer ROI as ROI. We add the ROI boundary to the map. The empty curly braces indicate the default visualization setting. So ROI is simply the layer name that appears in the layer panel. And then we have cloud mask function. Here we define a custom function called mask s2, like Sentinel-2. The function remove the cloudy pixel from every Sentinel-2 image before creating the annual composite. Then we have created another variable QA. Variable QA. Here we select the QA60 quality assurance band. This band contains information about the clouds and cirrus cloudy pixels for every image. Then we have the variable cloud bit mask and cirrus bit mask. The cloud information is stored as individual bits inside the QA60 band. So this line create a bit mask for bit 60, which represent opaque clouds. And in the next line, this line create a bit mask for bit 11, and which represent the cirrus clouds. So we have created another variable here using the bitwise, and we checked whether the cloud bit is equal to 0. If it is 0, that pixel is considered as a cloud free. And we have dot and function here. We also check the cirrus and the cloud bit. Only pixels that are free from both normal clouds and cirrus clouds are retained. And we have applied a function of return. It applies the cloud mask and remove all the cloudy pixels from the image. And Sentinel-2 surface reflectance values are stored as integers, as scaled integers. So dividing by 10,000 convert them into a reflectance values ranging approximately from 0 to 1. And finally, we have copy properties over here. We copy the image acquisition date from the original image. This is important because the animation uses the time information to display frames in the chronological order. And then we have created a list of the years, like we want it from 2017 to 2026. So I have used a list list sequence from 2017 to 2026. And then we have created annual composite. We have created a variable annual. We create a new image collection where each image represents one cloud's free annual composite. We have year dot map function. This map function loops every year in our list and perform the same operations automatically. We have created a variable year. This convert the current year into an earth engine number object, so it can be used in the earth engine function. Then we have load the sentinel imagery. It's really easy. Like we have just used this sentinel harmonized imagery, filtered it to our region of interest, and we have used the filter date from first month to 12 month and for 31 date. And then we applied the cloud pixel percentage, that is 15%. We have used the cloud mask function that we have defined above. We took the median and we clip it to our region of interest and saying it to return the imagery after applying all of that filters. So, and finally we have print the annual. And then we have set some of the visualization parameters, like how you can over here. It will generate a preview first for 2017, and then it will create the animation parameters. Okay, so now let's discuss the animation parameters one by one. Like the animation will cover the study area. It's this sets the output width of GIF to 900 pixels, and the this controls the animation speed at 2 at 2 frames per second. Each annual image is displayed for approximately half a second. Then we have set the CRS. This define the coordinate reference system used for the rendering animation. We have minimum, we have maximum values, gamma values, and the bands, width bands. And next we have created to print the GIF, and we have the download URL. So this create our download URL for the animation. Clicking the link, open the animation in the browser where it can be downloaded. Next we have MP4 parameters. It's uh, same as that of this, but it is somehow different. Its dimensions are different, and we are using the band 4, 3, and 2, and other things the same. And then we have the we have created a URL for our div. Now let's run the code and see it. Okay, so here we have 2017 imagery for our study area. We can just untick it and see just the image. And here we have the download link. You can also click on MP4 and you can click on here to see the animation. It will take some time to load over here. Okay, so here is our MP4. You can right click and it save image as. You can also save it like that. Okay, so here it will look like something like that. You can see the water increasing, decreasing its pattern and all other lens. You can create it for others, like at some points it's showing vegetation over here and at some points it don't have vegetation at all. So that's how land cover changes we can see from satellite imagery. We can also see it over here and we can save it in our folder. So that's a complete workflow of creating a Sentinel-2 time-lapse animation in Google Earth Engine. In this tutorial, we started by defining our study area, loaded the Sentinel-2 surface reflectance dataset, applied cloud masking to remove cloudy pixels, generated annual median composite from 2017 to 2026, and visualized the image in natural color, and finally created the downloaded MP4 animation. If you found this tutorial helpful, please like the video, subscribe to the channel, and turn on the notification bell so you don't miss future tutorials on Google Earth Engine, remote sensing, GIS, and artificial intelligence. If you have any question or suggestion, feel free to leave them in the comment below. Thank you for watching. I'll see you in the next tutorial. Bye.